We are into chapter 6 now. And the very first thing that we need to talk about in chapter 6 is an inverse trig function. You have dealt with inverses in our algebra classes. Algebra 2, college algebra, pre-calculus algebra, whichever one you took. You found inverses of things. We talked about, an inverse is when you reverse the x and y values. And we knew that only certain functions had inverses. They had to be 1-to-1 in order to be able to do that. In other words, it had to pass the horizontal line test. I want to talk about our trig functions. To do this, I am going to go back and reference some of the things that we did earlier. So unfortunately, since we haven't had class in person, I haven't been bringing these things up every day. But the last day I saw you, we took a test over graphing trig functions. So let's just think about those graphs. If I took the graph of sine, okay, we can obviously see that this would fail the horizontal line test. That is not a 1-to-1 function. And we know this is when we graphed from 0 to 2 pi. That's what it looked like. So if I take the entire sine function, overall that is not 1-to-1. If we are talking about the inverses, we are going to have to look at a portion of the graph. The notations for inverse, you might see sine with a -1, or you might see arcsine. Both of those things mean inverse. For the trig functions, what we do is take 2 of the 4 quadrants to look at our function over. We need 2 quadrants that will tell us everything about the graph. In other words, I need 2 quadrants that will give me the positives and the negatives. We want consecutive quadrants. We know right here this is from 0 to pi over 2. That's like quadrant 1. If I went with quadrant 2 though, I have more positives. I'm repeating those same values. I'm not getting the 1-to-1 piece. So we know that this keeps repeating. And if I went the other direction, I would get the negatives. Or if you think about our little all students take calculus. Okay, everything's positive in quadrant 1. I need 2 consecutive quadrants where sine is positive and negative. So if it's positive in 1, it's negative in 4. So what you need to know is if I'm talking about arcsine or sine inverse, if your original problem has that in there, you only have 2 quadrants to deal with. Quadrant 1 or quadrant 4. So the first thing I'm doing is looking at all 6 trig functions and figuring out which quadrants we would have to be in if I'm talking about the inverse. You have to have the positive and the negative quadrant for each. Okay. So cosine. Okay, if we split that up, our 4 quadrants, I'm just doing really rough sketches here. So cosine started at its amplitude and went down. And it looks like this. We know every time we are going to use quadrant 1. That will always be our quadrant, or our positive quadrant. So we will either use 1 and 2 or 1 and 4. If I'm looking at this, cosine is positive in quadrant 1. In quadrant 2, it is negative. So arc cosine or cosine inverse exists in quadrants 1 and 2. Positive quadrant and a negative quadrant. If you recall with tangent, that was kind of the weird one, that we already graphed it from negative pi over 2 to positive pi over 2. In other words, when we did our regular tangent graph, we were already graphing quadrants 1 and 4, and that's going to be the same for the inverse. again, you could use this little trick. Tangent is technically negative in both 2 and 4. We pick 4 so we can have consecutive quadrants without a break in our graph, without an asymptote in the middle. Okay, looking at our reciprocals, cosecant. Oh, that is really crooked. Not much better. Okay, cosecant is the reciprocal of sine. Essentially, it's going to do whatever sine does. When we graphed these, we would graph our sine or cosine anyway. And then, remember we had this type of graph from there. Sine inverse, we already said, exists in 1 and 4. That's the same with cosecant. It will do the same as its reciprocal. So it will be 1 and 4 as well. Secant is the reciprocal of cosine. So we know cosine looks like this. And so when we graphed secant, it looked like this. Just like cosine was positive in 1 and negative in 2, we had the same result with secant. So secant inverse or arcsecant exists in quadrants 1 and 2. Cotangent. Here's the thing that's different. Tangent, when we graph it in quadrants 1 and 4. So we have the asymptote on the end. Cotangent, if you remember when we graphed it, we just went from 0 to pi. And the reason was that gave us a complete section. So our cotangent or cotangent inverse, that exists in quadrants 1 and 2. Just like when we graphed it, we used quadrants 1 and 2. So today we are going to be evaluating these inverse functions. And what you need to remember is if you have sine, its reciprocal cosecant, or tangent, your inverse exists in either quadrants 1 or 4. If you have cosine, secant, or cotangent, the inverse has to be in quadrant 1 or 2. So the very first step I'm going to do on every problem today is ask what quadrant we have to be in. And it comes down to this. So sine, cosecant, tangent, 1 and 4. Cosine, secant, cotangent, 1 and 2. Alright, we're just going to start evaluating some now. Alright, so I want you to find the y that makes this true. This comes back to your unit circle, guys. If you are rusty on that, you might need to draw a blank one in practice. When I see arcsine, I know right away I have to be in either quadrant 1 or quadrant 4. I'm only going to get one answer to this problem. Because 1/2 is a positive number, out of these two quadrants I have to pick the one where sine is positive. So that will be quadrant 1. So you are giving me an answer in quadrant 1. What this means when I say y equals arcsine of 1/2, that's the same as saying the sine of y is equal to 1/2. So I'm saying in quadrant 1, tell me the angle where sine is 1/2. I did not specify in this problem whether degrees or radians. So sine is 1/2, whether you use your hand trick or your unit circle, sine is 1/2 at 30 degrees. Or if I had said radians, you would have to tell me pi/6. Your directions will typically specify if you're in degrees or radians, so just answer appropriately. Okay. Let's try some more with sine. So sine inverse, that's the same as arc sine. That means I'm either quadrant 1 or 4. This is a -1, which 4 is my negative angle. This is like saying, when does sine of y equal a -1? Okay, if you think about your unit circle, we're between here and here. Sine is your y value. Okay, we know if it's 1 or -1, it's on an axis. This would be the point 0, 1, so that's when sine is 1. This is 1, 0, that's when sine is 0. This is 0, -1. So sine is -1 right here. There are a couple ways you could answer that. You could tell me that that is 270 degrees. If I ask for it in radians, 3π/2. If you are checking your answers in the back of the book, they typically write it with a negative angle. We know that 270 would be the same as spinning down 90, so you could call that a -90 degrees. 3π/2 is the same as -π/2. I feel like you guys are probably more comfortable with the positives, and so that's fine. You can certainly answer it that way. Just be aware that if you're trying to check your answers, or if you're looking at an example in the book, they tend to write the negative. I do not care. 270 and -90, those are coterminal. Add or subtract 360, you get to the same point. So I don't care which notation you use. Okay, let's see. Again, this is sine inverse. I know if it's sine inverse, you are either quadrant 1 or 4. Because this is a -2, I'm dealing with the negative quadrant, which was 4. This is like saying sine of y equals -2. You're telling me when sine is -2. But if you remember, sine can only equal things between -1 and +1. So it is not possible for sine to equal -2. So this one is no solution. It does not exist. All right. Let's look at some more. This time I'm talking about cosine inverse. Cosine inverse is 1 or 2. This is a +1, so you pick the positive quadrant. However, if I'm talking about when sine or cosine is 1, that's on an x or y axis. Think about your unit circle. We're saying it's somewhere in here. Is the point 1, 0. Cosine is the x. So cosine is 1 right there. So this is at 0 degrees or 0 radians, since I didn't specify degrees or radians here. Cosine inverse, y equals cosine inverse of negative radical 2 over 2. So cosine inverse can be in quadrants 1 or 2. This is a negative, so you take your negative quadrant. You are going to answer in quadrant 2. This is like saying cosine of y is a negative radical 2 over 2. So we are finding where in quadrant 2 is cosine a negative radical 2 over 2. Again, the negative is just the part that tells me it's quadrant 2. Reference angle, if we think to ourselves, when is cosine radical 2 over 2? That's at 45 degrees, or pi over 4, if you're dealing with radians. So 45 degrees in quadrant 2, 180 minus 45 is 135. If I ask for radians, remember in quadrant 2 the numerator is 1 less than the denominator, so that would be 3 pi over 4. Again, on your homework, it's going to tell you in the directions to answer in degrees or radians, so you will not have to use both. Exact value would be radians, otherwise it'll say degrees. Alright, find the degree measure of theta for the following. Theta equals arctan of 1. So arctan, I can either have an answer in quadrant 1 or quadrant 4. 1 is positive, so my positive angle is quadrant 1. This means that tangent of theta equals 1. All we're doing in these inverse problems is giving the angle. I've told you the value of the trig function essentially. You're finding the angle that makes that happen. If we think about reference angles, we know that tangent is 1 at 45 degrees. Since we're answering in quadrant 1, 45 degrees is my answer. B. Let's make this a negative just for fun. Theta equals secant inverse of negative 2. Okay, so secant is like cosine, so it'll be 1 and 2. Because this is a negative 2, we need our negative quadrant, which is quadrant 2. So really what we know is that secant of some angle is equal to negative 2. Or if you prefer, that means cosine is a negative 1/2. If we think about our reference angle, cosine is 1/2 at 60 degrees. Then we need to put that in quadrant 2, so 180 minus 60 is 120 degrees. Okay, if your function is one that we do not know, if I said, for instance, theta equals secant inverse of 2.5, that is not one we have memorized off the unit circle, so you will have to use your calculator at times. Be very careful. My suggestion is just to never enter the negative angle. The reason is when you're dealing with tangent and cotangent, your calculator will give you the wrong answer at times. So to make our life simple, we will just always put in the positive and treat that as a reference angle and then put it in the quadrant we need. So let's look at that. find y in radians if cosecant y equals cosecant inverse of -3. So when I see cosecant, I know it does the same thing as sine. So it's either quadrant 1 or 4. This is a -3, so I need my negative quadrant. So quadrant 4. Excuse me. Okay, this is asking when cosecant is -3, or that would mean sine is the reciprocal -1/3. We don't know that one from our unit circle. So instead we are going to use the calculator. First thing I need you to do is make sure you are in radian mode, because I said to give an answer in radians. You might have to change your mode back and forth on your homework. To get our reference angle, I want you to do cosecant inverse of +3. Now, we don't have a cosecant inverse button, so remember these were the ones that we had to think about them a little bit more. We need to treat it as a sine, so we are going to do sine inverse of a +1/3. So you hit second sine 1/3. My reference angle in radians is about 0.3398. I want that in quadrant 4. So for your actual answer in quadrant 4, you have two options. You could realize that in quadrant 4 that's just spinning downwards, so you could tell me the -0.3398. That's how your book will answer it. Or we are in radians. In radians, you do 2 pi minus your reference angle. So I need to do 2 pi minus the 0.3398. And that would give me 5.9434. Again, the book, if you're checking, will have the negative answer. I will accept either of these. To get the 5.9434, you just treat it as a reference angle. So 2 pi minus 0.3398. Okay, B. Arc cotangent. Cotangent inverse. That can be quadrants 1 or 2. This is a negative, so that tells me quadrant 2. What this means is cotangent of theta is a -0.3541. We don't have a cotangent button. We know we're going to have to think of this in terms of tangent anyway. So tangent is the reciprocal of that. This is the one where if I just type in my negative, I will get the wrong answer. So I have to do it this way. To get my reference angle, you need to do tangent inverse of 1 over positive 0.3541. When I do that, I get 1.2305 if you round to 4 decimals. We need this in quadrant 2. Oh, hold on. I said in degrees. I did not change my calculator to degree mode. Whoops. Okay, switch your calculator over to degree mode. and then retype that, tangent inverse of 1 over 0.3541. So I get 70.5009 degrees. I need that in quadrant 2. So in quadrant 2, you do 180 minus your reference angle. So 180 minus 70.5009. I'm going to get 109.4991 degrees. Okay, so just put in the positive, treat it as a reference angle, and then answer in whichever quadrant you need. Have one final type of example. These I am saying you have to do this without a calculator. That means you're going to have to show me work. I want sine of tangent inverse 3 over 2. When I see tangent inverse, the answer to an inverse problem is just an angle. So I'm really just asking you to find sine of some angle. Since it's tangent inverse, I know that could be quadrants 1 or 4. 3 over 2 is positive, so that's quadrant 1. So what I'm going to do is draw myself a picture. What that means is tangent of my angle is 3 over 2, and we know it's in quadrant 1. So tangent is opposite over adjacent. Do Pythagorean theorem, find your missing side. A squared plus b squared equals c squared. Hypotenuse is always positive, so it's radical 13. So now I want sine of this angle. So sine, SOHCAHTOA, opposite over hypotenuse. So 3 over radical 13. Which is 3 radical 13 over 13. Do another one like that. I want tangent of cosine inverse negative 5 over 13. So the answer to an inverse is just an angle. All I'm asking is for tangent of some angle. When I see cosine inverse, that means it could be quadrants 1 or 2. Since this is a negative, that tells me quadrant 2. So I know cosine of my angle was a negative 5 over 13 in quadrant 2. So if I draw my picture, cosine is adjacent, so that would be the negative 5 over hypotenuse, that would be the 13. A squared plus b squared equals 13 squared. You get plus and minus 12 because this is in the second quadrant. Your y is positive or it's going up, so this is a positive 12. So tangent theta, tangent opposite over adjacent. And we get negative 12 over 5. So really, guys, we have done inverses a little bit before. The new piece is now you have to pay attention to your quadrant. You're only going to give one answer. When we talked about them before, we were just finding every time something happened. So this is your assignment. I would like this done for Monday, so email it to me whenever you get done between now